Hello everyone, my name is Oskar, and here we looking at malware that used in targeted attacks. It is my first video in English language. Previous videos was in Russian, so I will try my best uh, in recording such videos next. Okay. Here now we will look at malware that used in uh, attacks. It is This report was issued by Sophos, and here they're describing a USB worm malware that takes own roots from plugins. So I uh, briefly read this report, and uh, it talking about a malware that can steal information from air-gapped network. Uh, what is air-gapped networks? When Usually when we deal with some highly profile networks, I mean military networks or some security services, such agencies they're trying to use uh, air-gapped network. It means that they have own network that without connection, without direct connection to the internet or other networks. But in fact, such networks are not really disconnected from internet because if you have some systems or Windows system, you should to update your antivirus. You should update your systems, and you should, for example, upgrade your databases and doing many other things inside your air-gapped network. So, how system administrators made these operations? So they are using a USB. So, for example, if we have some antivirus, they are downloading updates, signature databases, and it's up downloading to the USB drive. Then they disconnect uh, it USB from computer which connected to internet, and bring this USB drive to the network which air gapped. So, and after this they upload information to this network. So if you look at this process, you may see that in fact there is a connection between air-gapped network and internet through the USB. So if someone will uh, find a way how to uh, infiltrate inside the air-gapped network, he can steal some information from it. So this report is dedicated to such situation, and experts from Sophos they're describing such attack. So we will try to look at the malware that used in this attack, and we will download this malware from Wix Underground website. Okay, here is a directory with paper and samples. We are interested in samples, and we will try to download some interesting sample. Uh, so we will open the GitHub repository of Sophos, where The indicators of compromise are provided. So here is a there is a six. Okay, 560 8 ED 43. Okay. So here we have two types of malware. First, it is a malicious loader, wsc.dll, and second, it is payload. I don't know exactly what to choose. Maybe we'll just download. We will just download two files and try to look at both of them. I think we need both. Uh, uh, we need both loader and payload because I think it is using a classical three files gem, which uh, usual for PlugX malware. So they using three files to execute a malware. First, it is a signed executable. Here, I think it is Avast because there was a mention. Second, it is a malicious memory loader, which decrypts and executes a third file. And third file, it is just uh, uh, a payload file, which contained a malicious functionality. I don't know exactly what to load. Okay, we'll try to load this file. Uh, this payload and this DLL because mm, there might be some differences between various loaders and we need exact same law. It is a best choice to have a uh, exactly same loader that used to that's supposed to work with this payload. Okay, unpack. We unpack the samples and we will rename it according to its original names. And it is Vast. Okay. Um, where it is placed? So looks like it should. And ideally, we need the first file. It is uh, signed Avast um, executable. But I think it might be difficult to find it due to oh, certificate is not valid. Why? Transparency. Mm, okay, it is just a virtual machine. And if I am attacked, it doesn't matter. Okay. Ah, okay. So, uh, attackers used a component of Avast antivirus, quite old. Of course, it contains a DLL side loading vulnerability, which provides opportunity to execute malicious DLL. Okay, here is some graphs public about using it in PlugX campaigns. Okay, we will try to load a payload uh, without first file, just using a run DLL uh, no, without original executable using a run DLL. Okay, so it is protocol executable 32. It is a problem because IDE freeware supports only 46-bit uh, uh, double executables files. Yeah, it can open and process it, but there is no some um, important components. I mean, for example, there is no signatures for Visual Studio, so it might be a problem. It contains various export functions, but I think most of them are uh, just just fake. Yeah, most of them just return some number. I think the most interesting is this. Okay. Mhm. Okay. Okay. Okay, so we discovered that there is only one real export function. So it is a DLL, 30-bit uh, 30-bit bitness. There is only one real export function. Uh, so in fact, it trying to uh, load some file that's stored as a data extension. Here I think it is AvastAuth.dat. Uh, it obtains a uh, file name of the payload, then it reads it. Firstly, it trying to look at the last, I think, 4 bytes. Okay, and this 4 bytes uh, mm, should contain data about okay. So it goes to the end of the file and obtaining a current position. It is like a size of the file. So that way, this malware obtains a payload size. Then it allocates a memory which equal to this value, and then it just reads a file to the memory to the allocated buffer. Mm, um, then there is some uh, encrypted commands. I think it is command which obtains address of the first function for execution, and maybe someone there it try to execute loaded loaded payload. Okay, so maybe we will try uh, to execute. Okay, we need to check other functions. So maybe there is some tricks. Okay, looks like there is no tricks about uh, executing here. Okay, so let's make a snapshot of the system. And of course, we need to disable internet. Oh, right. Let's disable it. Is reset.dll 7 decompile. So looks like there is no interesting. Okay. Okay. So here we add the exporting function. Let's enable the internet because here the by free there is only cloud-based compiler, so we need an internet. Okay. Mhm. First. Okay, so when we debug, we obtain information that so this function get model file name A, it just receives a file name of the executable which currently run. Uh, in real case, when the execution of this library was initiated by Avast component, it should be placed here at the C program data Avast as CVCP CP. But since we used run DLL, it just um, says that it ran from Windows sysvol 64. And here we need to change uh, this information because information about directory or about file which run this DLL, it should be used in next steps. So here we make some change. Avast SVCP. Avast SVCP. And so we need to check correctness. Yes, there is a listing, so we changed everything. Okay, let's make a snapshot. Okay, so here you see that there is a structure. Uh, this function looks first occurrence of the symbol uh, inside of string. Oh, I forgot that I googling um, information about functions in Russian, so I will use English. So this function finds the last occurrence of a character in a string. In the pseudocode, you may see that there is a string that we changed. It is a C program data avast svcp slash 2 dot exe. So it is a fake executable. And it tries to find the last this symbol. Okay. So okay. So here it says it form a string dot. It is an extension of the our payload. Mhm. Then it obtains a AvastAuth this string and okay. Mm. Look here. Yes, and after calling the function, there is a concatenation of two strings. It is a AvastAuth and first string and .dat it is second string. Then it just places this. So here it formed the file name of the payload, and then it will try to concatenate this file name with directory name of the executable that run the DLL. So here you may see AvastAuth.dat. It is second string, which will be append here to this. And you might remember that here we have this directory, and here we have a payload file. Look here. So here we have a exact file name of the payload. Let's make it here. Everything is okay. I don't know exactly what happened here. I will hope that it is not important. Okay, so here we have for a function, it is a big function, a get payload, which reads payload to the memory. Let's see, it's here, our styles. Let's compare it with size of the file. Mm, red decimals look hexadecimal. Yeah, exactly same. So 28A0B. Okay. Yeah. So here using this operator, there is a allocation of the memory. We should write. It is better to store this information about uh, address to the buffer. And here, program tries to set all bytes of at here at this address to the null, to the 0. It is read payload. Here is 3 arguments. Okay. Okay. Yeah. So it is just same payload. You may see that there is a pattern inside, but it will be better to look at the decryption algorithm. Yeah, of course, we currently can statically unpack, but we will try to look at the decryption algorithm here at this library. So payload already read, and what will be next? Okay, it is just saying I think there is some calculations and checks. Okay, then so the looks like it is okay. So I say 10 symbols. Mhm. And it allocates. Okay, so looks like first 10 first 10 symbols of this payload, it is like a K, and next it is just a body of the payload. And here then it tries to allocate a memory with number size of file minus 10 bytes. So we obtained uh, this value. So it is size of file, and this is uh, size of allocated memory. Okay. I think it is like an encryption algorithm, uh, decryption algorithm. and because there is a cycle and because there is a cycle. Let's try. So it is, I don't know what is this. It is like a 0. Yeah, it's E6. Yeah, it's like a counter thing. So we are taking a first byte here. This 1 4. Okay, it does not. Just wait when it will write data to the. Oh, you might see that here, from here, it is a starting decryption of the MZ signature, and we will just put here breakpoint and click to the run and wait until the payload will be decrypted. Okay. So I think it is already decrypted, and we need just to find the script with dumping a memory, making a memory dump. So here there is a script. Okay. I think it will work. Let's open this dump in the. Okay, we can see that it is executable. Let's check this executable in the CFF Explorer. Yes, looks good. Mm, Concept, entropy. Looks like not packet, and it is good for us. Let's check file hash of this decrypted payload on the VirusTotal. Maybe someone already uploaded this file. No, no uploads here. Okay, maybe I will upload this file and make a comment with link to this video, maybe later. Okay. Protection change it and okay. Hmm. I think when the free library function will be called, it will call some function inside this library, like unhook, something like this. So we need to check. Uh, okay, so I think that's all for this uh, for this part. Next video will be dedicated to analysis of the payload. We will try uh, to make some static analysis and uh, compute it separately, not here, and try to finish the analysis and detect and extract indicators of compromise. So that's all for this. Thank you very much for the attention. Uh, Goodbye.